Hello, Data Standard community. I'm your host, Shayna Weldon, and this is the Data Standard audio experience. We have a great guest today on our podcast. We have Jose Unpingco, a Senior Director for Data Science and Machine Learning at West Health. He has Python software development skills and high-level applied mathematics, including deep learning and neural networks, machine learning, and optimization. Welcome to the show, Jose.
All right. Thank you. Thanks for the opportunity. I appreciate you having me on.
You're welcome. I appreciate you willing to be on here to start off the podcast. Yeah. To start off, can you please just go ahead and introduce yourself?
Okay. My name is Dr. Jose Unpingco. I am the Senior Director for Data Science at the West Health Institute, which is a nonprofit medical research organization. I'm also a lecturer at University of California, San Diego for machine learning and data science, both the undergraduate and graduate programs. And I'm also the author of 3 books using Python for scientific applications, including machine learning, statistics, and signal processing.
Wow. That is so impressive. So you work at West Health. What services does West Health provide?
So West Health is a what's called a nonprofit medical research organization. So its mission really is to do research into integrated healthcare models that improve health outcomes, and in particular reduce healthcare costs. That also include non-medical needs for the seniors in the U.S. So the whole idea is to come up with better models and influence sort of policy development that influences the well-being of seniors in the U.S.
What type of data do you work with?
So we have a wide range of partnerships with other institutions, other hospitals or healthcare providers, or other institutions that provide services, like, for example, meal delivery services to the seniors in the U.S. So as a result, we have a wide variety of data that sort of depends on what the motive of the research is. So we have a lot of, for example, claims data. These are like after you go, you see, yes, you're for your doctor, for example, there's usually a payment, right? A payment the insurance company makes. So we have lots of that kind of data. We have also lots of state and federal other data that the government collects. Data on poverty, for example. We have geographic data where different people are located, where seniors are located, where concentrations of poor people are located in the U.S. And then we have also health, what's called encounter data, sort of like, what happened, like when you go to the doctor's office, they might always be typing in stuff, that kind of sort of encounter-based data we have. So we have a mix of different data sets, and a lot of the challenge is really combining or developing new data sets that address specific research topics.
Got it. Okay, very interesting. So I know there's a huge misconception about data flowing freely without defects, but in reality, it's actually dominated by defects. So how do you handle this in the industry?
So I think one thing I've noticed, in particular when I see students, they are under the impression that high quality data is just a mouse click away. I can just click and download this data. And then the value in the data science product is really in, the machine learning model or all that. So in their minds, it's really the value add comes from constructing this model. In reality, especially in the area that I work in, the data science value add actually begins at the point where you're determining what data should be collected that will lead to a valuable product. So the reduction or combination or imputation of existing data sets is really where the data science activity is most important, because this is where you're essentially putting a down payment on what the resulting value of the product will be. So you can't escape garbage in, garbage out. So it's really the refinement and the understanding of what needs to be collected to go to a specific goal, to wind up with a valuable data science product at the end. So, and then that involves cleaning and talking to people who have domain knowledge, specific issues that drive towards the motives, what the collaborator wants. So.
I heard you mention garbage in, garbage out. I know this is one of your terms that your professor taught you, but you also have a term called health data paradox. So what exactly does that mean?
So when you're talking about sort of the cost of healthcare, what happens is, so machine learning models consume a lot of data, right? So if you're talking about health data, they're going to want to consume a lot of health data. So where is there plenty of health data? Well, there's plenty of health data among people who are chronically ill, right? If you're admitted to the hospital, believe me, you're going to generate a lot of high quality data just by the fact that you're constantly under observation, you're being treated, right? So from a cost standpoint, the ship has sailed, right? From a cost standpoint, it's a little late to worry about that when you're already, already in the ICU getting all these. So yes, the machine learning models are going to be heavily instrumented. But the problem is the selection bias drives the models to essentially predict, sick people will get sicker, right? And that's not an interesting question to ask when you're dealing about, for example, a cost effective. You're interested in the ones who have yet to be sick, right? Who have potential. And those are the ones for which you have very little data, right? Because if you're not sick, you're obviously not going to go to the doctor and constantly be measured for this and that. So that's really the paradox. Where there is strong data collect is amongst people for whom costs have already happened, right? So that's part of the data collect. But that's not in particular where you're most interested if you're interested in reducing the cost of healthcare and making healthcare more available to, in particular, seniors in the U.S.
Okay, thanks for that description. I know it's also a little difficult to talk about, but no, thanks for explaining that, though. What is the situation in which the risks of models are calculated based on individual outcomes and not aggregate outcomes?
That's an excellent question. So if you're dealing in a situation where the results of your data science activity can dramatically impact an individuated person, right? You're not impacting people, you're impacting persons, right? So for example, if my healthcare model says that Mrs. Jones should not get like a particular surgery or should not get a particular intervention, the potential downside from that could really be severe. So if the machine learning model is only grading on sort of the minimum mean squared error, right, which is sort of an averaged effect, right, then you've missed the individuated risk that can happen, not just in medical, but in military applications or financial applications. If somebody doesn't get a loan or has some severe financial downside from the output of your model, you can't go around saying, oh, well, on average, it just works, right? Because the severe outcomes aren't captured sort of in the metric that's being used to collect and qualify the model, right? So it's very seldom, and I've actually never seen it in practice, where the mathematical objective of a machine learning model is sufficient to satisfy the organization's needs. I've actually never seen this. It's always that the value add is a combination of the objectives of the machine learning model, but as they're influenced by the other needs of the organization. So for example, we have a lot of privacy and security needs, right? No one's going to care about the outcome of this particular model, how great it is, how low the minimum mean squared error is, if the other needs of the organization are unfolded into how value is recognized by the model.
Yeah, we're getting into data analytical issues. I guess, what is the biggest challenge that you face in your industry?
So I think anybody dealing with sensitive data, I think security and privacy, as you know, with all the constant news reports of everybody, being held hostage for data being hijacked, et cetera. So anybody who deals with any kind of secure information, in particular healthcare information, big challenges for security and privacy. So maintaining trusting relationships with the other collaborators that you have, not just that you say, we're secure and we're good. You have to be in a situation where you have policies and procedures in place that can demonstrate artifacts to that effect, that can head off problems before they happen. So I think security and privacy are big issues and are going to become bigger issues as more data becomes, or the value of data insofar as it recognizes issues of privacy and security become more common. And then the other thing that we have is data collection is not free or cheap, in particular in this area. So the ask for collecting data that directly influences a stated goal is something you have to be cognizant of. So collecting data actually that drives towards a specific goal isn't so easy when you're dealing with healthcare data. So in the world I work in, those are the two most dominant. I think the security and privacy one is going to become a bigger deal when you're dealing with other kinds of industries. I just think the healthcare one is sort of, healthcare, financial, military. I mean, they're already up into that, but I think that's going to become a bigger deal in the future.
Security, privacy, and collecting data. Okay. So we at the Data Standard are building a community for data enthusiasts to collaborate and to connect. And so what can we do for you?
So there's a great overview of the research that we do here at the Institute on the westhealth.org site. So that's a great place to keep up sort of on the overall. There's a lot more to it actually that I was able to get into. We also have a GitHub site where we support a number of open source products, in particular visualization products. So you can go to github.com/westhealth. You can see some of the open collaborations we have regarding visualization tools in particular, and other things that we do for the community. And then if you're interested, there's also my own GitHub site, github.com/Unpingco has all the Jupyter notebooks corresponding to the books I've written. If you want to connect. So there's plenty of ways that you can collaborate with us on a technical level, on a research level. So we're happy to talk to anybody who's interested.
Okay, thanks for listing the websites. And then also, where can viewers find you? At that same website you just listed at GitHub, or?
Yeah, for sure. So it's github.com and then / my last name. It's P as in Peter, I, N as in Never, G, C, O. And you'll find all of the other material I have on there. I'm involved in a number of other open source projects as well. So yeah, We're happy to collaborate in what we have. We have papers we put out at the various Python conferences. So we're a big Python shop here. So.
Well, thank you. And thanks for being so willing to be part of a community. So you can find us at the Data Standard at www.datastandard.io. This episode was also sponsored by Pandio, and they're innovating the tech space, and you can find them at pandio.com. But back to you, Jose. Thank you so much for your insight and for being here today.
Oh, thanks. Thanks for the opportunity. I really appreciate it.